In this tutorial, we'll be looking at one of the ways that nodes communicate with one another. In the last tutorial, I mentioned there are three ways in which ROS nodes communicate with one another, that is, pass messages between one another. In this tutorial, we'll look at one of those ways, which is topics. So what is a topic? You can think about a topic as the name given for the type of messages that are transferred between nodes. These messages, the stream of messages rather, have a defined type. Now, this type may be an int, for example, and let's say that images are coming in from your depth perception camera, your laser scanner, or any type of sensor you have affixed to the robot. This data will be of a particular type, and what the topic allows ROS to do is the topic allows ROS to be able to take the information from one node and transfer it to another node. So in the camera example, if it is your depth perception camera is taking in laser scan data or image data, and another node has to process this data, the mechanism by which these nodes transfer this information is via topics. Now it will be a lot easier to understand once we start actually using topics. Another important thing to remember about topics is the mechanism that you communicate. One topic, the topic that is getting the data and pushing it out, is known as the publisher. So the node that would be taking in the camera data is known, and putting it onto ROS then will be known as the publisher. The other node that is taking this information and doing something with it is known as the subscriber. Now, before the nodes start to transmit data between one another, they must first announce or advertise. As you see here, if you look at the ROS topic list, these are basically the advertisements of these topics. Now, like I said, these tutorials will be very practical. All we need to know is how to create a publisher node and how to create a subscriber node. Before we start writing any type of ROS code of all, the first thing we need to do is we need to create what is known as a workspace. So create a new terminal. Now, a workspace is essentially where you store a group of like code. What we'll do is we'll create and use one workspace throughout the tutorial series. Though you should know it is possible to have many workspaces. However, for our purposes, one workspace will be sufficient. We need not concern ourselves with how Catkin works. All we need to know is that Catkin, which is the workspace type ROS uses, all we need to know about Catkin is that it generates various files and directories that we are going to need as we continue writing code for our robot. Okay, so let's start by making our Catkin workspace and initializing it. We're going to call it simple Catkin workspace. Now we change directory to the source folder within our newly created workspace. And once we are in the source folder, we initialize the workspace with the catkin init workspace command. Once we have our Catkin workspace made and initialized, we are going to use the Catkin make command. What this command does essentially is it builds all our source code that is in our Catkin workspace. So simple Catkin workspace. Once we are within our workspace which we created, we type the Catkin make command. Now you'll see a lot of output while this is being done. Now, if we list the contents of our simple Catkin workspace after we run the Catkin make command, we'll see that we have two new folders. We created the source folder, but we'll also see a build folder and a develop folder. Now we need not concern ourselves with the build folder as much. However, the develop folder is very important because what it does is it allows our system to be able to use all the code we created in our workspace. In order to ensure this, we need to type this command. Now what this command does is it ensures that our system can find all the code that is contained within our workspace. Before we can start creating our publisher and our subscriber, we need to create what is known as a package. The reason we created the source folder is so that we can add packages to it. What is a package? You can think about a package, as its name suggests, as a container that holds things like our code and our data that we will be using on our robot. The package, however, allows a good organization within ROS so that all our code can be organized, so we can separate things like code for vision, code for machine learning. We can separate all our code into different packages. Now each package has what is known as a dependency. Don't worry about too much about that right now, as later on we'll explain that in depth. What you should do is, in order to create a package, you change your directory to the source folder. Once you are within the source folder, you use the command catkin create package, and you can call your source folder whatever you like. Let's call it simple code, and the dependency will be the ROS Pi package. Now, If you are using C++, it would be ROS CPP. However, in this tutorial, I'll be using Python as our main language. So, all you need to know is that when you create any type of package, you need to use the catkin create package command. Then you will type the name of the package you want to create, followed by the dependencies that is things that package will be using. Hit enter and your package will be created. Now that our package has been created, let's examine our package was created. Now from within the source folder, list the contents, and you'll see our new package here, simple code. Change directory to our newly created package. List its contents, and you'll see that there's a source folder, there's a package.xml file, and there's a C make list.txt file. For now, let's focus on the package.xml file. We open it with our text editor. In my case, I prefer to use Nano. Now, if we look at this XML file, we see a number of things. The first thing we see is the name of the package. Simple code. Do not change this. We see the version number. We see a short description of the package. And we see things like who maintains the package, the license of the package. Scroll down. And the dependencies of the package. Now, remember previously when creating a package, we use the ROS.py dependency. If it is that for some strange reason the package was not added, or you are experiencing some error with your package, you can check this XML file to ensure that it has all the dependencies required. Now that is all we need to know about the package.xml file, so you can exit. All our code, or all our nodes rather, will be within this source directory within our package. The first thing we are going to do now is we are going to create our publisher and our subscriber. Let's create our topic publisher node. The first thing we're going to do is create a shebang to let the operating system know that is a Python file that we are creating. The next thing we need to do is to import ROS.py. What ROS.py does is ROS.py contains all the things that we'll be using, all the functionality, all the basic functionality we'll be using, and need in every ROS Python that we're creating, we need to import ROS.py. Our node will also be publishing messages of type int32. So from the standard messages, ROS standard messages dot message package, we need to import a 32-bit integer type. We also need to initialize the node that we are creating. And we'll call it Remember to use single quotes. My publisher. Sorry, underscore. Now, what this next line does is it advertises the node that we just initialized. So we initialize the node in this line, and this line advertises the node that we just initialized. Now after we initialize our node, what this line does is it sets the rate in hertz. It sets a variable with the rate in hertz that we want to publish our topic. In this case, is a rate of 1 hertz, which is 1 times per second. Next, we create a variable called count, and we initialize it to 0. This is the variable that we'll be publishing for other nodes to subscribe to. We create a while loop. Now we're going to say while not ROS_PY that is shut down. Now what this line does is the ROS_PY that is that shut down returns a boolean value. If it is the node is ready to shut down, this boolean will be true. If it is the node is not ready to be shut down, this will be false. So this is our exit condition for the while loop. Pub that. Now this is a line that actually publishes our current count, which is the message we want to send. We increment it, and then we sleep for a little bit. So once you have created your file, make sure you save it in the directory where your package is. So I saved mine in the simple code and that in the source directory of that package. Ensure that you do this. After we have finished saving, we are ready to create our topic publisher. The first thing we need to do is to change the directory where this package is located. So we're already inside the simple Catkin workspace. We need to change directory to the source folder. Then we change directory to our package folder. Change to the source within our package, source folder within our package. And you'll see that we have our file that we created here. However, we can't use this yet because it is not executable. In order to make it executable, we need to change the permissions of our file. Do this. And you see now the file is highlighted green, which means it can now be executed. Now let's make sure everything runs as expected. We open a new terminal. Remember all this time, guys, make sure you have your ROS core or terminal ROS core running. Otherwise, you won't be able to use the packages and the file that we just created. So just to be sure that everything is working, I closed everything and we're going to start a new ROS core. Now the ROS master is started. Open a new terminal. Now before we use the ROS run command, there's something very important we need to do. We need to set the source to simple pattern workspace /edel/sttup.sh. After we have done that, the next step is to run our file. So ROS run simple code my publisher.py. Okay, so it's running. In our next terminal, to prove that it's running, we start a new terminal. And we use a command before, which is ROS topic list. And you see the count topic. ROS node list. And if you look at the node, you see the My Publisher node is running. So you have the My Publisher node, and you also have the count ROS topic. To prove that this topic is working, what we'll do is we'll use the ROS topic echo command, and we'll echo the count topic, its value, to the terminal. As you can see, at the exact rate of 1 Hz, or just once every second, it increments by 1. You can hit Ctrl C to stop this from running. Now that we have verified that our publisher is working, what we can do now is we can start working on a subscriber node. Okay guys, so what we are going to do now we're going to create the subscriber node. As usual, we put the shebang to inform the operating system that the type of file we are creating is a Python file. Next, we import ROS_py, and from the ROS standard messages, we import the 32-bit integer type. Next, we define a callback function. Now you must remember that ROS uses callback functions a lot. Once you have a node that is subscribed to some topic, once you have a node that is subscribed to some topic, every time a message arrives that is associated with that callback function, it is called. In our case, our callback function will simply print message.data. It will simply print the message that was received from our publisher node, which will be the count from the count topic. Now after we define this callback function, the next thing we need to do is we need to initialize this node. And we're going to call this node My Subscriber. After we initialize the node, what we need to do is we need to subscribe to the count topic that we had in the publisher. If we go back to the publisher file, you see here that we had the count topic. What you're going to do now is you're going to subscribe to that particular topic. So subscriber equals ROS.subscriber. Subscribe the count topic. We have the type 32-bit integer, and we'll be using our callback here. So like I explained before, once the message comes into our subscriber, the callback associated with that message is called. In this case, the count topic, message from the count topic, we'll go to our callback function, and all our callback function will do is our callback function will print the message that was received from the count topic. It will print it to the console. Now, the last thing we need to do is we need to give all the control back to ROS. Don't worry about too much about this right now. Just add this line here. You save this. Remember, you save it under the package that we created in the source, and the name is mysubscriber.py. Now, before we do anything, I need to ensure that your publisher node is running. If you can remember, just run simple code mypublisher.py, type this into your terminal, hit enter, ensure that your publisher node is running. What you need to do now is ensure that your publisher node, your Python file for the publisher node, is unexecutable. Now you can go back if you can't remember how to do this. Once you have change the permissions on your publisher node Python file, the next thing you need to do, source simple catcan workspace /eval /setup.bash. Set that source. After you do that, ROS run simple code my subscriber.py. Oops, we have a little error here. Standard messages dot message. Sorry about that, guys. Go back. And as you can see, the subscriber node is taking all the information, all the messages that are sent by the publisher node, and the subscriber node is printing it to the console. If we go back to our code just to review, we have a publisher node. When creating a publisher node, you import ROS.py, you specify the message types, you initialize the node, initialize topics. In our case, we are publishing a count variable at a rate of 1 Hz, and we are incrementing it every second. And it is the exit condition for the while loop is while not ROS.py.is shut down. So this condition will be true, so this node will keep running. The subscriber node, on the other hand, what the subscriber node does is, using a callback function, it subscribes to a particular topic of the message type that is specified, and using the callback function it does something. So in our case we have the count topic, the count topic in our publisher node, and that count topic is of type int32, and when a particular message comes into our subscriber node, the subscriber node simply prints that message to the console. What this ROS.spin function does, remember that the ROS.spin ensures that the function will only return when the node is ready to shut down. And that brings us to the end of this video. Thank you for watching, and I hope that you have a little bit clear understanding now of how to use publishers and subscribers within ROS. If you need anything clear, you can look at the video again, or you can check out the ROS wiki. It has a lot of valuable information. Thank you for watching. Goodbye.